Alright guys, excuse my voice because I have been sick this weekend. We're going to be working on the second part of 6.6, distributing property, and instead we're going to be working on factoring. So we should start on page 487, and this is going to be part 2 of our videos. So factor an expression says when numeric or algebraic expressions are written as a product of their factors, the product is called factoring the expression. And what I want you to think about is that this is in the same lesson as distributive properties. So let me just show you with example number 4. This is where we're going to end up. This is where we start. It's almost like doing the opposite. It's like undoing distributive property to make distributive property. Okay? So we're working backwards. Instead of starting here and going to here, we're starting here and going down to distributive property. All right, let me clear this up and then we're going to begin. All right, so the biggest thing that you need to remember about factoring is greatest common factor. Okay, it's got the word factor in it. Okay, it's really, really important. To find the greatest common factor, they show using prime factorization, and that's certainly one way that you can do this. I kind of like to list my factors and compare. Now with least common multiple, I always had you use the biggest number and work your way from the biggest number. This time I'm going to have you use the smallest number. And what I want you to do is think of it like this. For this example, we've got 8 and we have 12. And so keeping the number 12 in mind and thinking of the factors of 12, I'm going to find my factors of 8. So I know that 1 times 8 are the first two factors for 8. Well, 8 does not go into 12, so I'm going to have to keep going. So I know 2 times 4 makes 8. And so now, again, I'm working from this direction over, and I know 8 doesn't work, but 4 works with 12. And that's my second greatest common factor, or my greatest factor for 8. So I know that 4 is going to be the greatest common factor between 8 and 12. So here's how we're going to use that information. So now we're going to take that 4 and we're going to put it on the outside of the parentheses. And on the inside of the parentheses, I'm going to find what 4 into 12 would be. So 12 divided by 4 would be 3. And 8 divided by 4 is 2. And this is going to be my answer, 4 times 3 plus 2. Now if I want to check my work to make sure that I did it correctly, I can use distributive property to check my work. I can say, here's my little rainbow, right? 4 times 3 would be 12, plus 4 times 2 is 8, and that's how I would check my work. But my final answer is 4 times 3 plus 2 in parentheses. We've got H, I, and J. I'm going to do H with you just so we go over this one more time before I have you practice it on your own. Again, I'm going to find the greatest common factor, and I'm going to always use my smallest number first and work through the factors for that, keeping in mind 21. Okay, so my factors for 9 would be 1 times 9. 9 does not go into 21, so I know that's not going to work. So the next thing I do, okay, come up with the next set of factors. That would be 3 times 3. All right, does 3 go into 21? It does, and so I know that I'm going to use 3. So here's what I'm going to do. 3 is on the outside of my parentheses. 9 divided by 3 is 3. 21 divided by 3 is 7. Now, if you want to double check to make sure that you couldn't have come up with a better greatest common factor, look at these two numbers in here, 3 and 7. Do they share anything else in common? Like any other factors in common? The answer is no. If the answer was yes, then it means I should have gone one more time and done something different, and you would have to change it all up and erase and start over with a bigger number. But in this case, I see that 3 and 7 don't have anything else in common, and so it's 3 times 3 plus 7 in parentheses. So I'd like for you to do I and J on your own, and when you come back, I'll show you the answers. Pause the video now. All right, and here are my answers For I got 14 times 1 plus 2 in parentheses. And for J, I have 8 times 10 plus 7 in parentheses. And J took me a little bit of time because 56 has a lot of factors. But I just kept working at it and looking at my big numbers and saying, okay, does 56 go into 80? No. Does 28 go into 80? No. Does 14 go into 80? No. Does 8 go into 80? Yes. And then I worked from there. Alright, so it does tell you that prime factorization of an algebraic expression contains both the prime factors and any variable factors. For example, the prime factorization of 6x is going to be 2 times 3 times x. So remember that 6x is the same as 6 times x. So if I'm finding the greatest factorization, or if I'm factorizing this down, then I'm going to have 2 times 3 times x. You see how that works? That the x is in a multiplication problem with 6, just like if it was, just like if this was 18, that's the same as 6 times 3, and then I would bring down the 3 still and say, okay, 6 is 2 times 3, and that's what 18 is. Well, this is saying 6 times x is 6 times x, which is 2 times 3 times x. Okay, prime factorization, it still works with the algebraic expressions. So now, we're still looking for the greatest common factor. And I want you to remember that. Greatest common factor is the biggest part of what we're doing when we're talking about factoring. So, for this example, we have 3x plus 15. So, one of our factors is 3x, and one of our parts is 3x, and the other one is 15. So if I'm doing this, I know that it's going to be 1 times 3, and the x is still there, but we're just talking about this, and that 3 would go into 15. So I know I'm going to factor out 3. Now if I do 3x divided by 3, let me just show you what that would look like. 3x divided by 3, these 3's cancel out, remember? And so you're just left with 1x, or just x. And then 15 divided by 3 is 5. Again, remember how I told you that you can check your work by redoing your distributive property to check your to make sure that if you were going backwards that it would still work, and that would still make 3 times x, which is 3x, and 3 times 5, which is 15. It would still make 3x plus 15, and so I know that that is a good answer. So my final answer is 3 times, and in parentheses, x plus 5. Because remember, I'm just finding the greatest common factor, and with 3x and 15, the greatest common factor that they both share is 3. Alright, so now we have K, L, and M. Again, I'm going to go ahead and do K with you, just because I think you need more examples than what they gave, and then I'm going to have you do L and M on your own. So right now we're going to do K, so don't pause the video yet. So for K, we've got 16 and 4x. Remember, I'm always going to take the smaller number and factor that. So I know that this is going to be 1 times 4 times x, but remember, we're just not going to think about that right now because it's just a multiplication problem. And is 4 a good number to work with 16? It is, so I know that that's the number I'm going to use to factor out. So immediately I put that on the outside of my parentheses. Now I'm just going to go through each of my things. For 16 divided by 4 is 4, plus 4x divided by 4. Remember that looks like this. 4x divided by 4. The 4 is just cross simplify, and I'm left with x. So my final answer is 4 times, and in parentheses, 4 plus x. You don't need to put 1x, just x. Now you're going to do L and M on your own, and then when you come back, I'll show you the answers. Pause the video now. Alright, so our answer for L is going to be 3 times x plus 6, and our answer for M is 6 times 6x plus 5. And so I think L is just identical to the other ones that we've been doing, but M, I don't end up with a 1x, So I just want to look at that with you. So I knew that 30 wasn't going to be a factor of 36. 15 is not, 10 is not, but 6 is. So when I know that I can divide 36, divide by 6, I know that's going to be 6. And don't forget that it's 6x. And so I have 6 times 6x plus 5. Because of course I did 30 divided by 6 as well. All right, so factor and expression, guys. Just remember that when a numeric or algebraic expression is written as a product of their factors, this is called factoring the expression. It's like undoing the distributive property. Okay? So I'll see you in school. Let me know if you have any more questions.